Iran has been working for decades to build a powerful missile program that can stand as a symbol of national pride and defense independence, and its ambitions in this field have grown stronger every year. The country views its missile capability as a crucial part of its strategy for deterrence and self-defense, and for many it represents the spirit of resistance against pressure from abroad, as well as a technical achievement born from limited resources and heavy sanctions. The external design of these missiles is shaped by both necessity and intention, from the long sleek body of the Shahab series to the more compact tactical systems. Every detail reflects a mix of engineering function and visual strength. When Iran parades these missiles through the streets of Tehran, or launches them from hidden bases, the exterior serves not only a technical purpose, but a political one. The world sees a nation asserting that it can no longer be ignored. The materials used on the outside vary depending on the model. Some use strong metal alloys, others use lightweight composites that can handle high temperatures and resist radar detection. The smooth lines and dark coatings are designed for both aerodynamic efficiency and symbolic effect, showing modern craftsmanship in a country often isolated from international trade. The exteriors may look simple compared to those of superpower nations, but each line tells a story of adaptation and innovation under restriction. For Iran, the exterior of missile is more than hard, where it is a message to its citizens and to its rivals that the country can build complex technology on its own. The bright colors used in test displays and military parades are often painted to inspire pride and project confidence across the region. Inside these machines lies a very different story. While the outer shell projects strength, the interior reflects the challenge of combining limited resources with advanced science. Iranian engineers have learned to integrate solid and liquid fuel systems depending on the mission. Solid fuel offers the advantage of quick launch readiness and mobility, while liquid fuel gives greater control for long-range trajectories over time. Iran has shifted more towards solid fuel designs as they allow storage and deployment from various mobile launchers. This means that in moments of high tension, Iran can move its systems quickly without long preparation. The internal electronics have evolved as well. The guidance systems, which were once based on older imported technologies, have been upgraded through domestic research. Many reports suggest that these systems now use a combination of gyroscopic sensors and satellite signals. Improve accuracy, though still not as advanced as Western guidance networks. They represent steady progress. Each layer inside a missile, from propulsion to control circuits, demonstrates how Iran has been learning through experience and experimentation. The engineers focus on reliability in tough conditions, since their equipment often faces environmental extremes, from hot deserts to mountain bases, where temperature changes can affect performance. When it comes to performance, Iran has built a range of missiles that cover short, medium, and increasingly longer distances. The short-range tactical models are designed for quick regional response, while the medium-range ballistic missiles are built to reach up to 2,000 kilometers or more. This gives Iran the ability to reach potential targets across the Middle East and beyond. Models like the Sejil and Khorramshahr have drawn global attention because of their speed and payload capacity. The Khorramshahr 4 is reported to carry up to 1,500 kilograms of warhead weight and reach speeds approaching Mach 16. These numbers suggest that Iran has moved from basic rocketry to sophisticated ballistic systems that can challenge regional defenses. The performance of these missiles is not only measured in distance, but in readiness and precision. Iran has been testing ways to improve its targeting through satellite guidance and maneuverable re-entry vehicles. This effort aims to make their strikes more accurate and survivable against modern missile shields. While some analysts question the accuracy, claims the pattern of development shows clear improvement year after year. Iranian scientists often describe their approach as one of persistence. They test, learn, adjust, and try again. Every new launch adds data analysis, leading to better propulsion, fuel stability, and aerodynamic control. The performance results show that Iran is not seeking parity with global superpowers, but a practical advantage in its region to ensure that any attack on its territory would come with a high cost for opponents. The idea of safety in missile development takes on a very specific meaning in Iran, since these systems are instruments of deterrence rather than tools of daily defense. Safety is about control, reliability, and command structure. The Iranian government maintains a tight centralized system for launch authority, Designed to prevent unauthorized use or accidental firing, the command and control protocols include multiple verification layers to ensure that only top leaders can approve launches. Storage safety has also improved over time with underground bunkers and hardened silos built to protect missiles from potential preemptive strikes. These facilities keep the missiles secure from surveillance and sabotage. Iranian officials have often emphasized the importance of preventing accidents, especially after early test failures that resulted in explosions and loss of equipment. Through those experiences, they have refined their safety systems for handling fuel loading, transport, and launch readiness. Crews are trained to operate under strict supervision using procedures meant to minimize the risk of human error. Though secrecy surrounds many aspects of these protocols, international observers note that Iran has demonstrated increasing discipline in its testing and operations. Their approach to safety mirrors their overall defense doctrine, tightly controlled, deliberate, and always under political oversight. The unique aspects of Iran's missile ambition lie not only in its technology, but in its strategy. While many nations develop missiles through open international cooperation, Iran has been forced to rely almost entirely on its domestic resources and limited partnerships with a few allies. This isolation has shaped a culture of innovation under constraint. Iran's engineers have reverse-engineered old, imported systems from the Soviet era and transformed them into new indigenous designs. They have adapted fuel chemistry, software control, and aerodynamic structure using local materials and university research institutions. The result is a missile industry that is both resilient and independent. This independence serves as a major selling point for the Iranian government, which presents every new missile unveiling as proof of national strength. The mobility of these missiles is another key factor. Mobile launchers and underground tunnels allow Iran to move and hide its arsenal, making detection difficult for rivals. These mobile capabilities increase survivability and strategic unpredictability, making it hard for adversaries to neutralize the missiles before they can be used. Iran also emphasizes cost efficiency. Its missiles are designed to be affordable by local production standards, which means the country can build large quantities without exhausting its budget. This approach allows it to maintain a steady state of readiness while signaling self-sufficiency to both allies and adversaries.